Cardiff University. His academic background lies equally in the discipline of English studies, being reader in English at Cardiff before transferring to the School of History and Archaeology in the late 1990s. His scholarly interests are primarily multidisciplinary, cultural history, and especially the ways in which disparate forms of evidence, material, literature, and linguistic can productively be combined. And his range of study covers a wide area of Northern Europe in the 2 millennia of the Christian Common Era. He's a former editor of Medieval Archaeology and president of the Viking Society for Northern Research, and currently vice president of the Society of Antiquaries of London. Actually, are you still vice president?
No.
I've got a feeling. I had a feeling
months out of date.
That was out of date. Yes. This evening, he's going to be talking about the Justinian plague, and I'm very pleased to say that the paper on which this talk is based is now accepted and will be in Archaeological Journal in the next few months. So, John.
Lovely. Thank you very much indeed. I'm trusting that the mic is placed just about right for you to hear nice and clearly. I had wondered if I ought to apologise, but I'm not going to for bringing on Valentine's Day a subject quite as unfrivolous as that of the bubonic plague, but it's also Ash Wednesday, and I think it matches the sombreness appropriate to that too. In all seriousness, I think there is something very positive about our ability to understand even sort of dreadful events of the past, and that the degree of interdisciplinary work that is involved in this is equally something very much to be celebrated, if anything but in a frivolous manner. Now, the best known pandemic of bubonic plague is the Black Death. This killed about half the population of Europe in a period of just 4 years in the mid-14th century, inevitably with huge consequences in social and economic history. Its effects in Asia and North Africa were also profound. However, the first clearly described pandemic outbreak of bubonic plague in the Western world is what has long been known as the Justinianic plague. This struck the Byzantine Empire in AD 541 and progressed to its capital, Constantinople, by the late spring of 542. There, it was described in eyewitness detail by the courtier Procopius, and in the Levant by John of Ephesus. Further historical sources testify to the rapid spread of pestilence to the westernmost parts of the continent in Iberia and Gaul, either by land or by sea. Both Welsh and Irish annals speak of exceptional mortalities in these isles in the later 540s. The bacterium that is the pathogen of bubonic plague, Yersinia pestis, is hosted by fleas, which are hosted in turn in the fur of rodents. Those rodents are great gerbils and marmots in a reservoir area of Central Asia, and black rats when lethal outbreaks spread to Europe. Archaeogenetic analysis of human skeletal remains from early medieval burial sites in Europe has recently confirmed the presence of this bacterium. With both the Justinianic plague and the Black Death 800 years later, the pandemics followed and were probably catalyzed by major and rapid climatic changes to colder and wetter conditions. Characteristically, once you've had your first outbreak, the plague will then surge in the human population in a cyclical pattern, broadly at 15 to 20-year intervals, until its virulence diminishes. And that diminution comes about through genetic evolution within the bacterium, the classic case that a parasite can't afford to kill off all of its host population, alongside precautionary measures and indeed the growth of immunity in the surviving human population, those all being strengthened. Now, at present, I know of more than 50 positive identifications of Yersinia pestis from more than 10 sites of the 6th to 8th centuries AD. The first such identifications were from 2 sites within just 20 kilometres of each other in Bavaria. A larger sample was published in 2019, and indeed a few more cases have been reported since. In that 2019 paper, the title of which is on the slide there, Marcel Keller and colleagues reported 4 positive identifications from one English site, Edix Hill in Cambridgeshire, but that number has now been raised to at least 13. There is, in fact, information on even further identifications at Edix Hill, which actually I'm not currently at liberty to share, though do be assured that makes no substantive difference to what I'm presenting this evening, which is concerned with the first and the worst outbreak of the plague in the 6th century in Europe. That additional evidence largely involves further categories of probable and possible identifications, and there is, in fact, another further article in preparation which shows evidence for a recurrence of the plague in the community of Edix Hill around the end of the 6th century, and indeed one individual who can be identified specifically as a victim of the pestilence recorded by the Venerable Bede under the year 664. Now, the cladogram, do you see that? Oh, no. So I've got a pointer here. No, I'm not. Is that working at all? No. Well, that thing down on the bottom right-hand side is a cladogram. The cladogram, which we've got on this slide, shows 9 specimens from Europe, which allow for full genomic sequencing of the bacterium. And interestingly, this reveals that one specimen from Edix Hill, in grave 78 there, is a variant that is one so-called SNP, or genetic mutation, ancestral to the type represented by all the other samples. Now, a total of 27 high-precision radiocarbon dates from human skeletal remains associated with positive samples were reported in 2019. The chronological clustering of the results from some sites we can see in these tabulated data indicates, for instance, that the 3 samples from Sandouchard represent a separate outbreak of the plague, most probably in the early 8th century. The remaining 24 dated samples in that table then could represent a single continuous phase of activity, although if you look just above the Sandouchard at the bottom of that table there, you will see that it's equally clear that the 6 samples from Lunelvier, which is near Marseille, also cluster relatively late in the group and very plausibly represent a local outbreak around the end of the 6th or in the early 7th century. With both Sandouchard and Lunelvier separated out, the remaining 18 dates reported by Keller et al. In 2019 form a relatively tight population in so-called normal distribution, that's shown in the bottom down there too, when modelled as a single phase of mortality and burial. There are, however, just 2 samples, these may highlight, yes, up there at the top, there are 2 dated samples from Unterturheim in Bavaria, which are at the top of that table, which appear to predate the historical record of the outbreak of the pandemic in the early 540s. The red line that you've got on that collected distribution of these dates represents the year 542. Individually, those 2 dated graves from Unterturheim have poor statistical agreement with the single-phase model, which is called First Pandemic Europe 1. Now, the question of whether those early dates from Unterturheim could be treated merely as statistical outliers, quantifying the level of imprecision that radiocarbon dating can involve, is best addressed via a closer examination of the evidence from Edix Hill. Early Anglo-Saxon graves here were first recorded in the early to mid-19th century, and after the excavation of a substantial cemetery in the parish to the east, Barrington, in 1880, the burial ground at Edix Hill came to be known as Barrington A. It was rediscovered in the 1980s, and the Cambridgeshire Archaeology Unit, which is now Oxford East, conducted excavations from 1989 to 91 aimed at determining the extent and condition of surviving graves. The report was published by Tim Mallim and myself in 1998. The archaeological evidence recovered represented a minimum number of 148 individuals, but from 115 graves. There were no fewer than 14 graves which could be identified as double or multiple burials, most of them contemporary and side by side, although some in vertical sequences of successive interments. There are also multiple cases of redeposited bone from previously disturbed graves, probably left behind in the 19th century. The preservation of the human skeletal remains was generally good, and there is a thorough report by Corin Duhigg. It could be inferred that the number of burials excavated was probably around 50% of the original number in the cemetery. Chronologically, the period of burial appeared in the 1990s to have spanned a century and a half, from circa AD 500 or so to around the middle of the 7th century. Further research since then has refined our chronology of early Anglo-Saxon graves and grave goods, and we can now put a date estimate of Cal AD 650 to 675 at 95% probability on the latest identifiable grave at Edix Hill, which is grave 91, extending that span just a little bit. The distribution of the Yersinia pestis positive burials at Edix Hill is striking. Analysis and interpretation of the site in the 1990s had noted that the distribution of epigenetic osteological trays tended to cluster in such a way as to suggest a zoning of the burials into household plots, with, as you can see on the left-hand side there, a tighter clustering of closely related males, that is those ringed in blue, and a wider distribution of females with the same genetic characteristics, which is consistent with a social pattern of inter-household exogamy. In other words, women would move from a paternal household to another household on marriage. A distinct group of graves towards the southwest of the site, which is box A in the plan on the right there, many of them being double burials, which are linearly placed in the softer fill of an Iron-Age ditch, has a very high proportion of Yersinia pestis identifications. The other identifications are more dispersed, but not obviously randomly scattered, with another cluster in the central area of the excavations and several apparent pairs or other correlations. It was especially with that distinct southwestern group that it initially appeared implausible that the burials representing this outbreak of the plague at Edix Hill dated no earlier than the 540s. The judgment that the burials might predate the historically recorded inception of the Justinianic plague was based upon the grave goods deposited in the female graves, and especially on the types of beads and the brooches, such as those that are underlined in red on the drawing of the grave goods there from grave 106A. These artifact types are consistently ones that are truly definitive of a phase A in the seriated national chronological framework of early Anglo-Saxon female grave goods, and more precisely, they belong to a subphase F, or female A2A, within the chronological framework for nearby East Anglia, that is, cemeteries in the neighbouring counties of Suffolk and Norfolk. In the national framework, Phase A was not investigated or analysed in any detail within itself. It must, though, precede the start of Phase ASFB, Anglo-Saxon Female B, and that was calculated as starting in the range Cal AD 510 to 545 at 95% probability. Within East Anglia, it could be shown that the national phase, Anglo-Saxon FB, partly incorporates a regional subphase, FA2B in East Anglia, and a Bayesian chronological model puts the end of FA2A and transition to FA2B in East Anglia in the period Cal AD 495 to 540 at 95% probability, which is, as we could expect, therefore, around about 5 to 15 years earlier than we could identify the start of phase AFB at a national level. The key point, though, is that if the chronological framework and calculated date estimates for East Anglia apply in neighbouring Cambridgeshire, the possibility of the Edix Hill female graves in that southwestern group, post-dating AD 540, would be mathematically calculated as below 2.5% probability. Statistically very low indeed, although not zero. Now, it's to be emphasized that it is female graves with Yersinia pestis that suggest a possible pre-Justinianic presence of bubonic plague at Edix Hill. The adult male and the pre-teen children's graves found with Yersinia pestis here are rarely as narrowly datable to phase as those with adult female grave goods. The dated male graves could either pre- or post-date AD 542 on present chronological understanding. Funded by a British Academy small research grant, 12 further high-precision radiocarbon dates on Edix Hill human skeletal remains directly associated with the presence of the bacterium were obtained in 2022. In 2 cases, these datings were from burials stratigraphically directly related to bodies that tested positive for Yersinia pestis, because these data can refine the modelled datings. The results are unambiguous, but the very opposite of what was expected. These data give little support to the prior hypothesis that the incidence of Yersinia pestis at Edix Hill predates AD 542. There are 2 results, if you look at the table on the left there, that would be consistent with that belief, from grave 85B, which is towards the northern end of the excavated site, and from grave 94, which is at the opposite side of the site. That one is just a probable rather than a definite case at one end of the line of Yersinia pestis positive graves in the southwestern ditch fill row. At 95% probability, grave 85B has a radiocarbon date of Cal AD 416 to 541, and grave 94 one of Cal AD 432 to 545. Now, these calibrated ranges are very broad, more than a century, because of a plateau in the calibration curve covering 100 years from circa AD Cal 440 to 540. But all of the remaining results, as shown in the plot on the right-hand side here, overlap sufficiently in their probability ranges that a model postulating that all of these identified cases of bubonic plague represent a single mortality event passes the statistical chi-square test and produces a higher posterior density estimate for that event in the range Cal AD 543 to 574 at 95% probability and a slightly narrower range at just 68% probability as shown there. This model does incorporate the high precision dates from the stratigraphically linked burials. Now, even with such a clear cluster in the decade or 2 post-AD 540, those early radiocarbon results from graves 85B and 94 could still either be outliers or indeed significant counterexamples. Their unmodelled calibrated radiocarbon dates are close to the 2 earliest results from Unterturheim in Bavaria I noted before. But grave 94 lies in a neat head-to-toe row with graves 66, 106 and 95, all of which are Yersinia pestis positive and all of which fit perfectly with the conventional Justinianic plague chronology. It's implausible that grave 94 represents a separate outbreak of plague. Grave 85 is in the northeastern zone, where the Yersinia pestis cases are rather more dispersed. Nonetheless, 4 cases here have dates which fit into the Justinianic plague combined dating horizon, and all of these graves have broadly the same orientation. At Unterturheim, the unexpectedly early radiocarbon dates are on burials 131 and 134, which are 2 of the 4 plague victims interred in a specially dug grave for 2 adult men and 2 children. Burial 133 here, a child which is at the top of the figure there by the knee of one of those adults, could not be radiocarbon dated, but the result from burial 132, which is one of the adults, is not consistent with the results from burials 131 and 134, despite these skeletons' unquestionable contemporaneity. The child's skeleton, 131, directly overlay the body of adult 132, who was interred with a sax as grave goods, that is, a sort of one-edged sword. The measurements of the blade of this weapon fall in between the criteria defining the well-dated types light and heavy broad sax in continental chronologies, but this is definitely not an object that should occur in a context of the 5th, or indeed even in the first half of the 6th century. Burial 133 at the top there, another small child, was buried with a set of beads comprising several specimens of the constricted segmented golden glass type, which is also characteristic of female Yersinia pestis graves at Edix Hill, but in combination with millefiori or so-called mosaic types, which are rare in Cambridgeshire, but also characteristic of the mid-6th century phase FA2B in East Anglia. Now, it's important to emphasise that the discrepancy in the calibrated radiocarbon dates between graves 85B and 94 and the remaining samples concerned is exaggerated by a plateau in the calibration curve covering a century up to Cal AD 540. Another way of understanding the potential scientific and mathematical pitfalls involved can be found by assessing the distribution of the radiocarbon ages returned rather than their calibrated dates, which we calculate from those radiocarbon ages. A pre-Justinianic outbreak of the plague should imply a statistically bimodal distribution of the radiocarbon age determinations between pre and post AD 542 outbreaks. Epidemiologically, we would expect discontinuous recurrences of the plague, not a continuous phase of infection. Theoretically, a distinct early outbreak could be represented by Edix Hill graves 85B and 94, together with the two earliest Unterturheim results, to be followed after a break by the larger group of the bulk of the Edix Hill and the other European dated cases. However, the conventional statistical test applied to the distribution of median ages produced by the samples shows that this data set as a whole is comfortably within normal distribution. It is not bimodal. The data as we have them imply a single pandemic outbreak in Europe and not two distinct events. Those four early results may simply be outliers in the specific sense that they represent the degree of inaccuracy that remains embedded in the radiocarbon dating technique. There can be no argument that misleadingly early dates are the products of a marine reservoir effect. At the same time, the Shapiro-Wilk test would allow the 6 dates from Lunel-Vieille in France also to form a single set in normal distribution with a mass of datings that manifestly represent the primary Justinianic plague outbreak in Europe. It's actually the local coherency of the cases at Lunel-Vieille which identifies a recurrence of the plague towards AD 600 here, not the radiocarbon results alone. On the other hand, it is the cumulative radiocarbon evidence that convincingly refutes the prior hypothesis based on artifact typology that female graves at Edix Hill may predate the 540s. Thus, there are intriguing cases which just might represent the circulation of Yersinia pestis in Western Europe before the Justinianic plague, but there is no conclusive evidence that they are correctly dated earlier than the 540s. One carry-away point here is that we're faced with fine chronological questions that are at present beyond the scope of science and statistics to revolve. Excuse me. But that is not a point, I might leave it at the previous slide just for a bit, that's not a point at which we should just smile or sigh in resignation and leave things at that. The establishment of a credible chronological and archaeological profile of the effects of bubonic plague in England in the mid-6th century has been greatly enhanced by radiocarbon dating and mathematical modelling of the results, but it depends no less fundamentally on multiple sources of insight: artifact typology and the sequencing of grave assemblages, historical records, and epidemiological knowledge of the behaviour of the pathogen Yersinia pestis. Identifying rather fuzzy mathematical data is one thing, we still have the conundrum of the fact that the few earlier radiocarbon dates appear independently to be supported by early-looking grave goods in the burials of the females who fell victim to the plague at Edix Hill. At this point, let me reiterate the point that the hypothesis of early 6th century pre-AD 542 datings was generated by reference to chronological schemes of indisputable relevance, but schemes which were not produced from the immediate area concerned. The National Chronological Framework did incorporate grave assemblages from Edix Hill and other sites in Cambridgeshire, but was not designed to address the earliest range of burials, precisely because we knew how great the regional differences in female costume were during that phase. We also have a regional scheme for East Anglia that does incorporate the earliest phases and which is consistent with the national scheme but requires some marginal but real modifications to it. Although it may appear counterintuitive, it is possible to accept certain propositions as true and useful at a cumulative national level, which are not true, or rather are not quite true, at a local or regional level. Despite the proximity of Suffolk and Cambridgeshire, there are some very marked differences in female dress accessories found in these two regions. The 5-spiral cast saucer brooches found in the Yersinia pestis positive grave 106A, for instance, the disc brooch in grave 96A, are types of extreme rarity in Suffolk, but frequent in Cambridgeshire. Especially important, we shall see, are the large disc or saucer brooches with applied plates of repoussé zoomorphic decoration, as in grave 95 at the top there. I've undertaken a new chronological seriation specifically for the region of Cambridgeshire. As already indicated, this has to be done only for the female graves. The male graves can simply be fitted straight into the existing national framework. For the new Cambridgeshire female scheme, abbreviated as CAMES-F, typologically I kept as close as possible to both the national and the regional East Anglian schemes. Those have proved to work, and this should allow for maximum comparability. I could start from a Cambridgeshire female data matrix of 197 grave assemblages from 18 sites with as many as 122 artefact types represented. More than half of those artefact types are different types of bead and brooch. Of particular importance has been the addition of the brooch types that are not represented in the East Anglian female seriation, but which are strongly characteristic of the regions to the south and west of Cambridgeshire, as well as Cambridgeshire itself, as shown on this slide. Now, these data produce a thoroughly satisfactory sequence. This is the convincing parabola representing the seriation by correspondence analysis. The grave assemblages are shown as a phased sequence with the phases defined on the leading type basis, in fact reflecting Beata Brugmann's sequence of 3 phases in the types of glass beads worn by women, A, B, and C, with subdivisions which match the East Anglian phasing as closely as possible, A1, A2, B1, B2, even subphases A2A and A2B, which I've mentioned before. There is an earliest phase, CAMES FA1, which is red on the far right edge as you look at it here, which is represented by 18 grave assemblages, which remarkably is about the same number as you've got in the green on the left-hand side of that plot. Most of these grave assemblages in FA1 being characterized by early brown and blue plain monochrome beads. As you can see, that group is extremely tightly packed in respect of correspondence analysis coordinates. Our ability to sort out the chronology of female graves in early Anglo-Saxon England was genuinely transformed by Beata Brugmann's comprehensive study of glass beads, published in 2004. The National Chronological Framework project, published in 2013, did challenge some of the schematicness of her framework, but that was essentially a matter of refinement and adjustment of an indispensable model. The need for nuance now proves to be as true between neighbouring counties as along wider parameters. To put it very simply, what appear as successive steps of introduction in one area are not so in the other, where the types rather appear simultaneously, at least as far as we can perceive. What correspondence analysis demonstrates is that the sequences in these neighbouring regions are consistent, but the East Anglian female phasing is only partially reflected in Cambridgeshire. The matrix that you see here is one that is set up in Excel, and even if you set it to the smallest possible font size, if you try and print it out, you need a sheet of paper 2.5 meters square. So look at the colours, look at the boxes. That's what you need to see just at the moment. This sorted matrix, which shows grave assemblages and artefact types from Cambridgeshire, reveals, in fact, two other conspicuous dividing lines within the range of seriated data, which might provide us with a more practical phasing of this set of female grave assemblages than the use of the beads alone. Those boundaries are not defined by bead types, but rather by the points at which, firstly, zoomorphic decorated applied disc or saucer brooches appear in the ordinated matrix, here the red box labelled ASB zoom, and then that at which the cast saucer brooches appear in a markedly dense cluster, which I've marked here in blue. What I could do then is turn to the radiocarbon data and Bayesian modelling to ascertain what might be the most informative model of a phased chronological sequence of the Cambridgeshire female graves on currently available data. This also reveals a very clear and informative result. Initially, we have 22 radiocarbon dated grave assemblages in that seriated matrix, and these radiocarbon dates convincingly represent a single continuous phase of burial activity from around the middle of the 5th to the later 7th centuries, precisely as we would expect for burials covering the early Anglo-Saxon period. A first subdivided model could test a sequence of 3 phases, as you saw on that correspondence analysis plot, defined by bead types and labelled Kames FA1 plus 2A, FA2B plus B1, and FB2 plus C. Now, it was fruitless to attempt to include a distinct opening phase FA1 in our models because we have only one dated burial that could represent that phase. Unfortunately, with all 22 available radiocarbon dates included, this model fails to achieve good agreement because one grave from Oakington has very poor individual agreement. Especially because of the impact this apparently anomalous case may have on the crucial boundary in the area of the sequence we're most concerned with, it seems wise at present simply to discount it as an outlier from further modelling. When that is done, the 3 phases with their associated radiocarbon dates, which are 10 in the earliest phase, 8 in the second phase, and just 3 in the latest phase that we've got there, produce an entirely satisfactory result. It's striking that there may be no representation at all of burials predating the 6th century in the data set, and I'd emphasise that we initially dated the start of Edix Hill at AD 500. The distribution of probability on the plot that you've got up on the right-hand side there shows that very clearly. In the middle of this sequence of phases, the middle phase, Kames FA2B plus B1, may have a very short duration, with the upper limit of the calculable span being 23 years at 68% probability, rising to 40 years at 95% probability, and the lower limits are actually 0 in both cases. To explore the comparability of the chronological frameworks that can be generated for East Anglia and Cambridgeshire further, it is possible to divide the Cambridgeshire data into 4 contiguous phases. We can indeed create a Kames FA2B characterised by the very few instances of the beads typical of East Anglian phase FA2B and follow that with a Cambridgeshire FB defined by the introduction of more numerous bead types. This model achieves a very high index of agreement, but the span calculations, which you can see towards the bottom of the table there on the left-hand side for the first three phases, are relatively brief and all still belong essentially within the 6th century. Phase FC, conversely, covers a much longer period despite having fewest datable grave assemblages. Reverting, though, to the apparent chronological sequence of the interesting brooch types I mentioned, a phase marked by the introduction of the zoomorphic applied disc and saucer brooches can be substituted for the bead-defined Kames Fa2b. This gives us a phase represented by 32 grave assemblages in the seriated matrix, as opposed to only 13. When modelling the associated radiocarbon dates, the difference between this and the previous bead-defined model is small. The transfer of single-dated grave, Edix Hill 78, which is, as I noted, Yersinia pestis positive, from FA1 plus 2A to FASB zoom. The highest posterior density estimates for the phase boundaries and the span calculations, as you can see, are almost identical. Now, let's try and pull some headline conclusions together here. The Justinianic plague appeared in Egypt in AD 541, reached Constantinople the following spring, and must very rapidly have spread across the Mediterranean and continental Europe to reach this part of England. We can plausibly suggest a community of about 45 people that generated the observed and inferable number of graves in the cemetery at Edix Hill, with an age structure that sets the size of the reproductive generation, as it's called, within that community, around 25. At least 13 of those people fell victim to the initial outbreak of pestilence and thus died at what may be treated as the same time. This represents a minimum mortality level of 29% in the initial Justinianic outbreak. In fact, possible cases could raise the mortality rate towards 50%. Amongst the victims, there were more males from females, but the difference is statistically insignificant. None of the certain victims has an estimated age at death over 35, implying that the impact on the reproductive generation of the community was substantial. All round, though, we can conclude that there was no significant selectivity in susceptibility to the plague, and that its victims do represent a random cross-section of the community. Not many people in this community got beyond 40 anyway. While the group of burials in the southwestern ditch fill strongly suggest a catastrophic outbreak in one household and the need to bury some victims concurrently, others in very close succession, the structure of the cemetery and the character of the graves imply that the community managed to absorb these sudden losses in terms of maintaining its usual funerary practices. The southwestern ditch group might be separated from its nearest neighbours in the cemetery by as much as 15 metres, but discrete household groups are themselves regular features of the overall cemetery layout. This specific evidence of natural but extreme mortality associated with a historically identifiable event has revealed a differentiation in cultural practice between neighbouring regions of 6th century England, Cambridgeshire and East Anglia, that we would not have perceived otherwise. The regional contrast is most marked in the dress accessories which dominate the grave goods of adult females. This is a facet of material culture in which identity is often positively and purposefully embedded. In East Anglia, phase EA, FA2b, is strongly marked materially by the introduction of the distinctive, highly uniform and numerous groups 16 and 17 great square-headed brooches. This change coincides with the introduction of new glass beads, the melon and reticella types. James Peake's analyses of the glass beads from RAF Lake and Heath for a Cardiff PhD showed that these bead types came into use along with a new variant of glass, which is essentially new glass manufactured in bulk in the Near East and modified with the addition of plant ash on the continent or in England. The start of East Anglia phase FA2b is thus a significant threshold in the sequence of manufacture and distribution of glass beads across England as well as of brooches regionally, and it has a model date estimate before Cal AD 540 at 95% probability. In Cambridgeshire, by contrast, the most substantive phase lying between a phase with types common to female phases FA1 and FA2A and the phase FB dominated by types common to East Anglia and Cambridgeshire, and indeed in the national sample, is defined by the adoption of variants of saucer and disc brooches, earlier characteristic of Sussex and Wessex. Our modelled radiocarbon data place the emergence of this phase around the middle of the 6th century, implying that material characteristic of the preceding phase remained in use in Cambridgeshire for perhaps a generation longer than in East Anglia. We can confirm that the Cambridgeshire and the East Anglian sequences reconverged during the later part of the period covered by female phase B in the national framework. From when onwards, the composition of female grave assemblages is fundamentally the same in Cambridgeshire, East Anglia, and much of the rest of early Anglo-Saxon England. What is clear, therefore, is that the sequences of material cultural phases in Cambridgeshire and East Anglia diverged in the middle of the 6th century. In the case of Cambridgeshire, the transitional phase separating the first and the middle, the B phase and the C phases, apparently closely followed the crises faced by the population after the climatic disasters starting in AD 536 and very likely the Justinianic plague of the 540s. In East Anglia, conversely, the chronological evidence is that a major material cultural reorientation had set in before those blows. It is intriguing if specific environmental and natural determinism was operative in the case of Cambridgeshire and not in East Anglia, except insofar as it may have crystallised a direction of change already underway. Contextually, it's important to appreciate the diversity and weight of evidence for shared material culture and social exchanges between the Cambridgeshire region and areas to the north and west in the central and southern Midlands early in the 6th century, an orientation away from East Anglia. These connections represent a network that was politically redefined in the mid-7th century as a kingdom and diocese of the Middle Angles. By the final decades of the 7th century, that territory had absorbed and extinguished the earliest West Saxon bishopric at Dorchester-on-Thames in Oxfordshire. The contested character of this area immediately to the west of Cambridgeshire is implied by the chronicle record of a Battle of Bedford in AD 571, by which a West Saxon prince, Cuthulf, won control over a territory dominated communicatively by the Icknield Way and Aikman Street between the Upper Thames and the River Lee. This event clearly coincided with a period of successful military expansion and the consolidation of power between the Severn and the Ouse, which effectively established the kingdom of the West Saxons in the 3rd quarter of the 6th century. What we can now also see is that also followed a recent phase of reorientation towards the south and west in the material culture of the dominant free stratum of society in the Cambridgeshire region. Political conquest and centralisation was a consequence of the development of wide-scale social networking and not a precondition for it. We could call this altogether a classic case study in historical archaeology. A historically recorded event and chronological horizon can be identified at a particular archaeological site. With that, we can start to unfold what that event actually meant in reality for that community. Contextually, there is an astonishing breadth of facets to what we can plot and compare as sequences of cause, effect, and change, in such a way as takes us away from simplistic monocausal determinism and reveals complex patterns of interaction. This sort of research can only be produced through collaboration between specializations and the ready sharing of results. What I would particularly stress is the value and the necessity of embedding osteoarchaeology and biomolecular archaeology fully within the longer-standing traditions of the study of material culture and historical processes. Thank you very much for your attention.
Well, that was a tour de force. Has anybody got any questions? Perhaps I could start out with one. The spread of the plague seems to have been far-reaching and very rapid, which usually means the rats hopped on a boat.
Yes.
But most of the sites that you quoted are well inland.
Yes.
So what happened in between?
Well, that is an interesting point. We've got some of those sites are beautifully on the Mediterranean coast, just as we would expect them, except one of those appears to be a second or third phase outbreak of the plague, not one of the original ones. I'm going to add another conundrum to this in a minute too. I think that the basic answer must be that even overland, long-distance communication and exchange was really quite extensive. It was normal in these times, the ability to move goods around, to make contacts, and for the and for whatever it is that is moving the plague. I mean, it's worth remembering that the outbreak is it Eyam, the village in the Peak District that quarantined itself in the 1660s. That was thought to have been brought in on a consignment of cloth brought up from London into the village. So, goods could certainly move it in that way. There's an interesting point about the behavior of rats, which is rats really thrive when it is warm and wet, and it turned cold and wet. And what we honestly believe happened is that there weren't more rats around, but because it got cold, they moved in. They moved closer to the human population and created a much bigger threat in that way. The archaeozoologists say they've got a little bit of a problem because while the presence of the plague definitely implies rats, they think there might actually be a hiatus even in the rat population of England, maybe Britain as a whole, sometime in the early Middle Ages. There are some very interesting things going on with all of this. We know of no host that we can think of other than the rats, basically, for transmitting it. But there are some interesting questions coming up here. So, yeah.
Does anybody else have any questions?
You can't be 100% certain it's the cause of death. There are people who get Yersinia pestis and survive. I think that figure is usually around the 2% level, so, it's not going to be very many indeed. We've also got to accept that when we're looking at a whole population like this, we can have false negatives. We may fail to identify Yersinia pestis, but it was actually there and a cause of that. I say we there as if I was actually doing this. No, this is that side of things is being done by people in white coats who know how to do it. I'm working on the results and trying to put those results in context, but we do function as a team. I think what we can say though is really increasing the degree of confidence we can have in talking about the impact of the plague on the community in terms of mortality, is that we're now beginning to see a signature which is the clustering of examples of Yersinia pestis, the number of double burials that we've got, That quadruple burial at Unterturheim is pretty unique. The fact that, even if the victims are in single graves, we might have 4 or 5 of those single graves very close together, looking as if they've got the vertical stratigraphy that would suggest they are successive burials. So those are the cases I would make. In fact, the scientific colleagues were first of all asking me, can you tell me of sites where we've got plague pits or something like that? The answer to that is no. It's true that at Lunevier, the man who published that said he thought there were signs of a more hurried burial of the plague victims there than we can see at Edix Hill, but it's in the sense of perhaps rather more randomly put together grave goods, not just the rapid, let's just get this body in the ground safely as soon as we possibly can. So there are inferences going on here. We are aware of the possibility that they're not necessarily going to be death if you've got the bacterium present.
Please excuse me if you covered this point early on, but I think I need you to go over it again. How much do you think you can extrapolate these results to sort of the wider areas and sort of give some sort of overall feel for, well, England in particular, but possibly wider?
It's a very good question, and I wish we could just give the answer that says, yes, we're really confident for all of these reasons. Without telling you where it is, I can reveal that Y. pestis has been found at one other site, but to the best of my knowledge, in one victim at that one other site so far. It is a slow and expensive process, so it's not as though we're screening hundreds and hundreds of graves and coming up with negatives all the time in that way. And of course, you can have false negatives. One thing I would point out, the report on RAF Lakenheath, the Eriswell Cemetery, very, very large burial grounds there, is going to be published by EAA by the end of this month. What is very clear there is that around about the middle of the 6th century, that is following both the Justinianic plague and the climatic crisis, the onset of the late antique Little Ice Age, the burying population apparently has dropped by 80% in that time, and we are seeing this sort of thing at other sites. All the evidence is pointing to us that where we're seeing continuing sites, the underlying population producing the number of graves there is a great deal lower. Now, of course, there can be multiple explanations of that. The population is dispersing, they're colonizing new areas, and so on. Actually, in the case of RAF Lakenheath, we'd say we think we know all the burial sites for quite a large area around, and we're not seeing anything that suggests there's a big shuffle around. So I think I would say there is circumstantial evidence that leads me to believe we are starting to look at a more general pattern here. And I think I would emphasize the point, that this is affecting children and it's affecting the reproductive generation. Definitely, they've got no advantage in being relatively fit and healthy, so that the ability of that community to continue reproducing itself for a generation or two ahead is going to be badly affected. In those circumstances, I think we may be seeing, there are things I can point to that say these are good reasons for me to believe we could well be seeing quite a demographic crisis in the middle of the 6th century from this. But I absolutely emphasize, more work. We need more data. We need more work on that to be able to confirm it. Thank you.
Can I just clarify on that and move it on a bit? That are you feeling that the people who are dying are just the young and the older ones aren't?
Actually, I think it's one of those sort of slightly statistical blips that our absolutely definite cases are all up to the age of 35. As I said, the number of people who are living into their 40s is extremely low anyway. And actually, again, without giving away anything that I'm not allowed to, amongst the possible, probable cases rather than definite cases, we've got a couple who, we would put in that old category of 40 plus. So all round, I'm happy that this is pretty much a natural cross-section of the community. But if you like, unlike COVID early on, it was definitely affecting children too. We've got 2 in Unterturheim. We've got children's graves from which the bacterium is coming back.
Are there any other questions? Yes.
Do you think that any comparable work in, say, the Balkans and Alexandria and places like that referred to by Procopius will be undertaken, or has anything of that sort started?
There is Europe-wide work, and I'm trying to remember the details. We actually had what was largely an online conference based in Hanover in 2020 on the first pandemic, where people were talking about research that they were doing, and there was certainly some from further east. I must admit, right off the very top of my head, I've got a feeling, one man gave some information on a site in Anatolia or something like that, where he'd picked it up. This is sort of underlying one of the points I was making about collaboration. I can understand a lot of this work is being done by doctoral students who are very, very protective of their data before they finish their thesis. I do understand that, but I do also emphasize, I would love to reassure them, that there are very, very few people around who are not going to fully acknowledge what they've done and where the source of these data are, and being able to put it all together, is really valuable. So I'm absolutely sure, more will come from that. The biggest problems are going to be that we have large areas of Europe where skeletal preservation is very poor indeed. So that, for instance, in Poland, where very, very good scientific work is being done, you do generally have the issue, such as, in fact, we've got in the west of Britain, that the soil types will be against skeletal preservation. Having said which, there's a new site has come up within the last couple of years, just north of Cardiff Airport, and we've got beautiful skeletal preservation there from this period, so those will all be screened for this. We will be able to do that. So I'm certain that more data will come, definitely.
Well, I'm very glad to say the RAI are sponsoring that particular excavation. So,
oh,
yes.
Diane.
So we've now gone full circle.
Great.
Well, thank you very much indeed. The people who died at Edix Hill clearly died in a lot of pain and a miserable way to go. But tonight you've managed, by using archaeogenetics, osteoarchaeology, statistics, C14 dating, artifact analysis, to bring them alive, excuse the expression, but also to show that even if it's just by germs, in that period, everybody was linked across the whole known world. And thank you very, very much indeed for a fascinating talk.
Thank you very much for the invitation to come along. Thank you.
It just leaves me to say that the March 13 meeting, we will be hearing from Professor Michael Fulford on Iron Age and Roman Silchester, 50 years of research in perspective.